Hello friends, my name is Wei Chuan. Today we'll be presenting a conference paper known as WebRL, Training LLM Web Agents via Self-Evolving Online Curriculum Reinforced Learning. This conference paper is published at ICLR 2025. It is ranked A star in the core conference ranking portal. This paper fits the assignment scope because it applies reinforced learning to train large language model agents for autonomous web interaction tasks, making it directly relevant to deep reinforced learning in LLM and agentic AI. Let's start off with the background of LLM. LLMs have already shown a massive potential in complex planning and logical reasoning, making them perfect candidates for autonomous agents. Web agents specifically hold unique potential for fostering authentic autonomous intelligence within our digital ecosystem. These agents are being applied across diverse domains, including code generation, database manipulation, and GUI interaction. The author of this paper introduced WebRL, a novel self-evolving online curriculum reinforced learning framework. Its primary goal is to train high-performance web agents using accessible open source LLMs. It hails consistent continuous improvement throughout the iterative self-evolution. That's all for my part. Now I would like to pass the floor to Bunjun to explain about the next part.
Hi, my name is Imanjun and I am responsible for the motivation and research problem for this paper. So for the motivation is to make a powerful web agent accessible without relying on expensive LLM. As LLM shows strong potential as autonomous agent, especially for web tasks which could truly autonomous digital intelligence, but current high performing web agent depend heavily on APIs, which are costly and time intensive. Open source LLM lack strong decision-making and planning abilities for complex web interaction because they have little decision-centric data during training. Previous attempts using imitation learning did not fully explore the online nature of web environments and failed to deliver continuous improvement. So the core motivation is to bridge the gap between open source and LLM web agent, enabling cheaper, more accessible to improve the autonomous web system. So for the research problem is how to effectively train performance web agent using open source LLM in real online environment. Specifically, the paper focused on training an open LLM as competent web agent in the web arena benchmark through reinforcement learning, moving beyond imitation learning or probability models. The goal is to enable open model to handle realistic long horizon web tasks across multiple websites at a level that rivals current LLMs. So my part answer, I will pass to the next person.
And my name is Dejuan, and now I'll be starting with the first challenges addressed. It is the insufficiency of training tasks. The online benchmarks such as Web Arena only provide 800 tough long horizon web-based tasks, which there is little when we are trying to do reinforcement learning because they rely on expensive trial and error, which using only Web Arena database will causes the AI model to overfit to those specific example. Moving on to the second challenges, the sparse and the cost of feedback signal. There is no task specification evaluation for website. For an example, an AI undergoing and reinforcement learning for games, you can get a constant feedback. You can get a positive feedback when you are collecting a coin. But for website, it cannot tell the AI either it is clicking the button is correct or not. Furthermore, the data given by the web arena are long horizon with average of 10 steps, which means in order to do a specific task, it will need a 10 perfect actions to do it. The last challenges policy distribution drift in online learning. It is because the lack of predefined data training database, which causes the necessity of online explosion. Thus, it will causes the drift of policy and it will causes the catastrophic forgetting and performance degradation over time. It is because they are using weights to train the model for main task, but they is actually performing a several tasks. For after a model have learned task 1, moving on to task 2, it will causes the huge change of weight. The change of weight will causes the model to forget for task 1. That's all from me, thank you.
Let's walk through the main framework proposed in the paper, WebRM. The goal of this framework is to train an LLM web agent to interact with websites more effectively using reinforcement learning combined with a self-evolving online curriculum. First, the process starts with web agent interaction phase. The agent receives a task, for example, finding specific information from a website. Then, the LLM web agent interacts with the web environment by performing actions such as searching, clicking, browsing, and typing. During this process, the agent observes the web page and generates a trajectory, which records all actions and observations step by step. Next is the self-evolving online curriculum module, which is one of the key ideas of this paper. Instead of using a fixed set of tasks, the system continuously evaluates the agent's performance and estimates task difficulties. Easier or suitable tasks are selected for training, while outdated or already solved tasks can be removed. At the same time, new tasks are added into the curriculum pool. This allows the curriculum to evolve automatically as the agent improves over time. After that, the framework calculates the rewards and learning signals. The reward is divided into two parts. The first is outcome reward, which is generated by an outcome supervised reward module, ORM. This reward measures whether the final answer is correct. The second is process reward, which evaluates the quality and efficiency of intermediate steps. These rewards are combined and used for policy optimization using robust RL algorithms like PPO or GRPO. Finally, the whole training loop repeats continuously, helping the web agent gradually become more capable and adaptive in solving web-based tasks. That's all from me. Let's move on to the next part.
Hi everyone, my name is Wong Yiping and I will be covering how WebRL was tested and the result is achieved. So to prove this framework actually worked, the researcher used a web arena like this is not a simple multiple choice test, but it is a highly interactive environment that simulates real websites like Reddit, GitLab, and other online stores. The agent has to navigate and solve the problem just like a human would, and they use 165 specific test cases to evaluate the models. So who is the competition? WebRL was compared against proprietary models like GPT-4 Turbo and GPT-4o. They also compared the WebRL against the standard open source model, specifically LLaMA 3.1 that trained with supervised fine-tuning. And they also compared with other reinforcement learning baseline. And here are the main results. When LLaMA 3.18b was trained with WebRL, its success rate jumped to 42.4%, and when they applied it to the larger 7B model, it hit a 47.3% of success rate. To put that in perspective, GPT-4 Turbo only scored 17.6%, while that means this open source model beat the best commercial API by over 160%. So why did it perform so much better? The error analysis showed three main things. First, the WebRL successfully reduced the getting stuck error. The standard model often get trapped clicking the same button over and over, but WebRL learns to adapt that. Second, the model gradually learns how to adapt its action when encountering the failure through the curriculum learning and showing its ability to reduce the fail to recover error. Thirdly, the WebRL showed the lowest rate of sort at wrong page error, showing that it has a deep comprehension of the relation between the task and the web pages. Thank you, that's all from me. I will now pass it to Hong Yi.
To wrap up our evaluation, we need to ask why does WebRL succeed where others fails? The author proved their design through an ablation study. First, they found that without the self-evolving curriculum learning, the agents hit a low performance ceiling because it cannot generate new and harder tasks to challenge itself, where we can see that the yellow line actually performs much worse than the orange line, which is the normal WebRL. Second, when they remove the replay buffer or the cal constraint policy update, the model performance actually degrades over time, and it suffer from catastrophic forgetting, meaning it was learning new tasks but completely forgetting how to do the old ones. These three components are essential for stable, continuous improvements. Next, we'll look at the conclusion. WebRL successfully bridged the massive gap between open source model and expensive closed source model for web tasks. By using autonomous curriculum and smart reinforcement learning, the Open Llama 3 model can outperform GPT-4 proprietary model by over 160% on Web Arena-like benchmark. The significance of this research is huge, as it democratizes AI. It proves that developers do not need to rely on expensive APIs to build highly capable autonomous web agent. Last but not least, we'll look at our personal insights. While WebRL is a massive leap forward compared to past model that relies on static, unchanging task set, it still have notable limitation. The framework relies heavily on sparse binary feedback, meaning it only gets a 1 for total success or 0 for failure at the very end of a long web task. It doesn't receive intermediate rewards for getting steps partially right. Addressing this process reward issue is exactly where I believe future research should focus next. Thank you for listening to our presentation. That's all.